Today we will be talking about the configuration and change management for BEXIS. With configuration and change management, we mean the normal disciplines to prepare the environment for the software development itself. It's not about the software itself, it's about how to configure the software, the environment, and then get everything ready to be more productive. For that purpose, as usual, I will go through some reminder slides from the previous talks to scope the talk, and then we will dive into the detail of configuration and change management in our system. Okay, as usual, we have this conceptual model that is basically the cornerstone of our system, because as you may have watched the previous videos, BEXIS is a data management platform for science. So these are the main packages that we try to have facilities, functions, and services around them for the scientists. Around this conceptual model, we have designed this architecture, and today we use this architecture elements. Basically, some of the important elements here in this architecture are needed, or actually they will affect how we design our configuration and change management, as we will see in next slides. Inside this architecture, there are some application elements that we are interested in, like the core. For example, here in the previous one, the core functions is something that we want to highlight for the configuration management. And then the modules, as again visible here, this modules here, and this external utilities also here. There is a concept of contribution projects, or like external projects, that they are actually projects that are out of our domain of management, but they will be developing on top of BEXIS, and then they will release also freely out of our control. This kind of contribution are also affecting our configuration management, so that we have to have some consideration how they will get contributed, how they will get our source code and their further work. So it's a matter of getting the releases and also contributing later to our code base. And also we have third-party libraries used in our system as binary or as source code, so we have to take them also into account in our configuration management. So by the configuration and change management, we actually have these three topics to discuss for today. First is the change management. This change management is basically toward the software development in terms of features, requirements, bugs, improvements, and so on. And then is the source control. That is a well-known subject. We will discuss how we are doing the source control. And then the release management with the requirements that we have for the release. What do we release, how we release them, and how we manage different aspects of release management. We will see these topics in a little bit more detail, but not even. We will talk a little bit about change management because it's well known, a little more about the source control, and also some details or customization we have done on the source control and the release, as we will see. For the change management, we are using the Scrum, actually like a customized version of Scrum. From the tooling perspective, we use Microsoft Team Foundation Server as our work item management. So work items here can be tasks, can be features, can be any change requests, and so on. And then we have the usual backlog items for the whole product, the tasks that are going to be assigned to the people and tracked via if they have done, in which iteration they have done, and what was their change set, and so on, for auditing and so on. And then from the backlogs, we have the sprints also, like monthly sprints or 4-week sprints, to see some progress during that sprint and so on. In general, we have a product backlog that is for the whole product, and then from that product backlog, we create or actually choose some items to have the release backlog. And then for each sprint, we choose a subset of the current release backlog as our sprint backlog. And then from the sprint backlog, we actually assign them to the available people. And then at the end of each sprint, we have some sort of an evaluation to see how far we have got. And then the same for the release, and then again, the same for the product. So this is a general concept of like work items in different backlogs, prioritizing them, doing them, and then evaluating as is suggested by agile processes and the Scrum to be specific. But from the source control point of view, actually we are using the source control system to keep track of the changes to the artifacts that we have. And the artifacts are like source codes, any third-party library that we are using, any user manual, or I don't know, help that we are generating, anything that is belonging to the product, as we will see in the later slides in the release part. And then, so the first feature of the source control is to keep the changes and enable us to reproduce them later, or to see the changes between a version to another version to see what has happened, if it's going to be changed, to be merged, to be reviewed even. So we use this concept of changes in the source control. And then there is like a nice feature with the source control systems to isolate work for different purposes. Like, for example, two different developers can work independently or in isolation on two different features, and then later they get their work merged. Yeah. So the second feature of the source control system that we are highly using it is isolation. And then when we have isolation, at some point we need to integrate the isolated outcome of the developers, which means that we will use the integration feature of the source control by, for example, by merging or rebasing and so on. So these three terms here will affect how we are arranging our source control structure, artifact structure, and so on, as we will see. We use the isolation, for example, for bug fixes. If there is a bug that should be fixed, we isolate that fix until it's tested, and then we will integrate it into the rest. Another example is the releases. When we are releasing, at the same time, there is a possibility that we have continuation of development for the next release. So there is a current release that is going to be stabilized, and there are some other people that are not involved in that release, but they are still working for the next version. In that case, we again isolate the current release, stabilize it, publish it, and then integrate it into the rest of the work stream. The same goes to the new features, like if it's a risky feature, if it's a big feature, and so on. We isolate also these things, and then when quality is enough, they will get merged to the upper or more or let's say higher quality code bases. And then in some cases the developer work is isolated. So for example, is a student work or is a new team member is not really familiar with the code, so in that case there is a chance to isolate his or her work and then evaluate it. If it's like enough quality in the code, then will be merged to the higher code base quality. So there are different reasons to isolate a work inside the team that are creating a shared code base, let's say. And then with the integration, actually when a piece of code has enough quality to be part of the final product, we use the integration mechanism in the source control basically by merging. So we have like multiple isolated work, they get merged to be a single code base. In some cases, we use the integration to propagate fixes, like for example, if it was a bug in version 1, there is a high chance that is also in version 2. So if we are going to fix it in version 1, that fix should be propagated to version 2 also. So in this case, we use some sort of integration mechanism to propagate that fix or that feature or whatever from one version to any other upper version. And also we use integration in promoting quality scenarios. So for example, we have different levels of quality, like unit test quality, integration test quality, and customer quality. This kind of levels of quality are actually represented in our source control. So with integration, we do some sort of testing, merging, and then attributing the quality level to the code base. So this kind of combination of isolation and integration help us to first identify different parts of our code, different quality levels, and what to do with those quality levels. So in general, we use commits for change preservation. So any change that is going to be preserved, we use the concept of commit. This concept of commit from version control tool to version control tool may have different names, but in general, commit is a noun or generalized noun, a term to preserve a set of changes together. And then we use branches for isolation. Anytime that we need an isolated area, we use the branches. We don't use workspaces for isolation because workspaces are like single user isolated areas, but they are not team level isolated areas. And then we use different kind of merging, like forward merging, I don't know, reverse merging, also rebasing for integration, which means that at some time we decide two branches or more than two branches to get merged into a single branch or to a third branch by mixing their commits together in a specific order using the merging logic. So from now I will try to explain how our branching mechanism is established and why. And then for that purpose, I will introduce how branches are used in general. So let's say, for example, we can have branches for team members, like any team member can have its own branch or even more than one branch for any purpose. Branches can be created for features, like feature branches are well known. If product is composed of multiple features, those features can be implemented in isolation and then eventually get merged into a higher level, like integrated system and so on. Branches can be also created for architectural elements, like for a component. If there is a component like a data access component that is used by multiple features, that component can be factored out into its own branch and gets developed in isolation. And from time to time, when it's ready or when it has enough features to support other business level features, it can be merged into the integration line. As I said, branches can be also created for releases. So if there is enough support to have isolated releases, like concurrent releases, bug fix releases, service pack releases, and so on, then we will also use branches for releases. One of the not really encouraged uses of branching is branching for safekeeping. Sometimes we just need to safekeep a released version of the software so that if later is needed, we can reproduce it, or to take it as exact as the one that was published. Like for example, in 2 years, if we need to go back to version 1, while now we are version 10, there should be a way to reproduce version 1. This reproduction can be done by safekeeping, can be done by tagging, for example, or can be done by having exact and untouched release, branches for that. So we use safekeeping plus tagging, as we will see later. And also there is a way in sometimes, like when there is a risky feature or a complex bug during release that we are not sure that we can make it or not, then we use ad hoc branching. This ad hoc branching are normally not planned in advance, and also they are not really long life branches. So it's like a temporary work. We want to refactor, we want to upgrade our, for example, .NET framework, and we don't know the effects. In that case, we create a temporary branch, do the work there. If everything is fine, we will merge it back to the main branch or whatever branch we have forked from, and then remove that ad hoc branch. So this combination of branching we use for different purposes. Is not that we just stay with one of these approaches. Basically, it's not possible. So I will explain in which cases we are using which type of branching, as we will see. So, but in general, our branching scheme is something like this. We have a master branch. The master branch is forked to a development branch, and then development branch is further forked to module branches. Modules are actually pieces of software that are facing the user. Is a bunch of functionality that are going together. In this case, for example, DCM is data collection module, and RPM is resource planning module. For each module, we have its own branch created from the development. So then it's obvious that DCM will periodically, when there is a progress in that branch, will merge back the improvements or the achievements to the development branch. So any development will happen on the module branches here, and then the dev branch here will actually keep the integrated view of the system. In this case, for example, system is just 2 modules, but in reality it's more than 2 modules, and so on. And then we have also standalone branches for the components, like for important components. Like DLM here is the data lifecycle manager. Is anything about data lifecycle management will go into that component. Or EXT is the extensibility component that is helping us to, for example, register new modules at runtime, to disable them, to enable them, and so on. So this kind of work we have architecturally designed to be standalone components, and then in the source control also we keep them isolated, and from time to time we merge their result into the dev branch. So on the dev branch here, from time to time we will see some contribution from DCM, some contribution from RPM and DLM and EXT in terms of commits that were done on these branches. And then an integrator, like a person that knows the whole system, takes care of consistency and compatibility of the committed changes into the dev branch. So, as I said, with the ad hoc components, ad hoc branches. So in this case, for example, a DLM underline data was created under the DLM just to make a feature, for example, for data preparation or something. And this is an ad hoc branch that will be merging to the upper one and then will be deleted when the feature is ready. It can go further, although it's not encouraged to do that, but it's possible if the features are going to be like divided to sub-features, if there is a risky work there, if there is something that we don't know how to handle it yet, and so on, but they will be aggregated into the upper one and removed eventually. So with this basic branching scheme, then we use actually the master branch is for safekeeping, which means that no coding happens on the master branch and also no changes can happen there. At all time, all test cases should pass on the master branch. So we don't allow merging to the master branch while, for example, any test case is not passed or is failed or even is not tested. Everything should be tested and then merged to the master branch. And because there is no coding, no changes, it's not likely to have any conflicts or like breaking code and so on the master branch. With the dev branch, actually the dev branch is designed to be the integration branch, so any integration happens there, so that if, for example, one developer is working on feature 1, another developer is working on feature 2, the integration of feature 1 and 2 happens on the dev branch. So there is likely that some conflicts or some configuration changes and so on happens there, but still no coding should happen on the dev branch. We have some policies to avoid coding on the dev branch in the next slides. But the point is that all the integration tests should pass on the dev branch. And also at least code should always compile on the minimum requirement is that when you merge something to the dev branch, the code should still compile. And then the quality indicator is that all the integration tests should also pass there, and then the merge is accepted. As I said, it sometimes happens that, like for example, configuration files like webconfig, for example, has been changed by more than one person. Those changes should be, those conflicts or those mergers should be fixed on the dev branch, but no coding, no fixing on the dev branch should happen. If there is such a need, the merge should be rolled back to the merging branch, like for example for the module branch, and then everything should be fixed there, and then the fixed version should be also again merged to the dev branch. So module branches are the place to add new features or to fix problems. They are always producing features for the next releases, not for the current release. Current releases are somewhere else. On the module branches, at least the unit tests should pass. But it would be good also to have the integration test pass here before merging to the dev, but it can be deferred to the merging time. There is some naming convention for the modules. That is always modules / the module ID, and module ID is set at the module definition time. Modules are forked from the dev branch, which means they will get updates from the dev branch if there is any update, and they also merge their changes to the dev branch when they have the proper quality level. The policy here is that to get merged from dev first, every time that you are going to merge something to the dev, you have to get merged from dev first, because maybe other developers have developed something. So in that case, you should get all those changes, test everything on your branch, and if it's safe, then merge your changes also to the dev. Module branches can, in some cases, be locked during the releases, especially if we are going to have like a big release or lack of staff to work on all the branches at the same time, but is not something that is necessary. The same description to the modules goes to the components, just the naming convention is different, and also the amount of unit testing is different, because the components are going to have a more extensive unit tests, but the general procedure is similar to the modules. So from the tooling perspective, we use Git. Also, we use the Team Foundation server. For the version control, we don't use the default Team Foundation server control version control, but we use a Git integration, so the TFS is integrated to Git. The source control happens on Git, but from the Visual Studio point of view and also from the TFS point of view, we are using the TFS VC. Our Visual Studio is integrated into this tool system, so every function that is available by Microsoft for Git is also available through Visual Studio. Additionally, we are free to use any Git extension on Windows itself, like shell extensions or any other third-party tool that our group are using it. But the main point of accessing Git functionality is through the Visual Studio UI. Externally, we use GitHub as a backup for our Git server, plus as a public access point for our code repository. We will see more on GitHub later. So there are some policies or practices that we encourage The simplest one are that branches are not just for individual developers. Branch can be used by more than one developer if needed, especially during like teamworks and so on. And vice versa, developers can work on more than one branch, but obviously one at any given time. As I said, branches can have ad hoc or temporary sub-branches as needed. There is no restriction on that, but there are some practices that if you need isolation, create branches. That's it. We promote work in isolation on new things and then get integrated as soon as possible. When you are going to get integrated into the upper changes, get merged first and then push your merges afterwards. So it's like pull before push in terms of Git. If there is a fix needed, like if you find an issue, that issue should be fixed on the deepest branch so that it is eventually propagated to the upper branches. Like for example, if you can fix it on an ad hoc, it would be better than the module. If you can fix it on the module, it will be better than on the dev, and the same toward the upper levels. The point is that anyone that is going to commit a change to a branch should maintain the target branch quality after merging. So if the target branch is saying that all the integration tests should be passed, you have to maintain that after merging. It doesn't matter how important is your change or how emergency is it, you have to have the quality level preserved after your work is done. And then with this small set of policies, hopefully we have like a code base with the identified levels of quality. And then with this quality levels, at the point of time, we decide to make a release out of it. The release is actually a coherent set of working artifacts, like a set of chosen features. These features are basically from the release backlog, and we have like every 3 or 4 months a release. So to make that release, we create, actually we have a release procedure that I will go through some of the main steps of the release procedure for BEXIS. But before that, when we say a release, actually we have some sort of a release material that is binary code, the source code, documentation, a sample demo site that should work with some data inside, and also we ship some initial data and workspace that is needed for the release software to work, and also some scripts like the database change scripts and some also like even the build scripts are part of the releases. Like the building scripts, like for example, the compilation script is also part of the build, so that later if you are going to build the same release, we have to use the same compilation that was compatible to that release, because from time to time maybe our system changed, so the script that is able to compile version 1 is not guaranteed to be able to compile version 2. So in that case, the compilation, DB change scripts, any document conversion like from Word to PDF, from Word to HTML, any branding information, any commands that we have used for that release, and also the packaging is part of the build, and we keep all these things under the source control too. So with all this material and procedure, then the release branch is forked from dev because we isolate the releases. So we need a branch for each release. And then the release is coming from the dev because dev is going to be the highest quality level before release. So we get forked from there. And then we name the releases by the 2 major version identifiers, like here releases /x/y. And then we use this branch to stabilize the feature set that are inside the release. which means that we don't add new features to the releases. We just stabilize whatever is inside the releases. If there is a new feature, it should go to the module. From there, it should be developed and then go to the development branch and later go to the next release. Usually, we use the release branches by all the team members because we need to get focused on the release, make it stabilized, and then release it. But in some cases, it's possible that just part of the team are working on the current release and maybe the others are working on new features for the next release. The release branch is basically built daily. It's just to guarantee that after every change or every small number of changes, the system is stable and is still working. When it's built, we stage it to a staging or a testing server, again daily or maybe bi-daily, and keep testing it as the new fixes are involved in the code. And then when it's ready, it's tagged, bundled, and published via our publishing procedure. That is also like a few steps of things to be done to get a release ready to be published or to be announced. So with this small description, let's go to the branching again. We had the master branch, the development branch, and now we have the R1, that is release 1, for example. This release 1 will have some work done, like for example here, when we progress, means that we are fixing or improving the features that are inside the release 1. And then at some point, we decide to publish it. When it's published, means the bundle is here, then the source code or this amount of change should be merged back to the dev, which we do it like this. And then again, at some point of time, it will go to the master for safekeeping. So then the code is released, so it's reproducible because no other changes are here, just the changes that are relevant to release 1 are here. The amount of change is integrated into dev for the next releases later, and also is safe kept into the master branch. So the same thing happens like if we have a patch on release 1 later in time, this change set also is here, integrated into dev, and also safe kept here. The thing happens again similarly for release 2. For release 2, you see that we have created another, another release branch. If you see from here, release 1 is involved, release 1.1 is involved, and also some other changes that have been made here by, for example, developing new features from the module branches. So any change from this time to this time is actually in the release 2. Then release 2 creates some changes again here by stabilizing the features, publishing it, and merging back it to dev branch, not to R1. R1 is not touched for any other purpose except for R1 changes. So the changes here go to the release branch and then safe kept. Again, if there is more like service packs, hot fixes or whatever happened on R2, they will be published and merged and safe kept. This is the procedure that we are following. There is a special case like this one that we don't like, but there is a way to support it, which is that when we are, why it will disappear? Okay, it's timed, I guess. When we are in release 2, we don't like to have a bug fix on release 1 at the same time because it's happened that it's merged here, which means that it was not part of release 2, which implicitly says that that bug may be reproduced in version 2. So this is something that we try to avoid by keeping distance, time distance between the releases. Like 3 or 4 months is practically enough to discover if there was any bug not identified during the releases. So in that case, we will either create this hot fixes as many as needed, or schedule the bug fix for the next release. But in emergency cases, there are some workarounds to have this also involved, fix on R1 and also involved in R2. But this is something that, as I said, we try to avoid. So with this branching scheme, then basically we isolate the release from any change that are happening on other branches or on other releases or even on the development branches during the release time. So whatever happens in the release time is just for that release. As I said, we support multiple live releases, but we don't like it because it makes some sort of complexities. This branching mechanism allows to reproduce the previous releases, because as seen here, this, and this, and this are the previous releases. They are marked here, and also marked on the master. So if needed, we can simply reproduce them by going to one of these branches, identify the proper tag or time and so on, and then reproduce it. Another nice feature of this scheme is that we can identify the exact version of the bugs when we see a bug. So that, for example, if a bug is identified now, we can go to the root cause of that bug. Like, for example, it was a bug on version 1, while now we are on version 4. In that case, we can decide to go and fix it on version 1, 2, 3, and 4, or to stay fixing it at version 4. So it allows us to be flexible on how to fix that bug and where, if, for example, different customers are using different versions. So when we are done with the release, then we need to integrate the release changes to the upper branches. In this case, actually, when we are going to start a release, we ask all the module and component owners to merge to the dev and then do some integration test on the dev. When everything is fine, we create the release branch from the dev with all the features included. And then during the release, we don't merge again from the dev to the release, because maybe some other things have happened on the dev that we don't need them or we don't like them to appear in the release. Like, for example, feature 1 to 10 are going to be part of the release, but one of the developer is working on the on feature 11, for example, and we don't want that feature to be part of the release 1. In that case, during the release, we don't get merged from the dev, but the other way is safe. So if something has happened on the release branch and is good enough, we can merge it back to the dev for other developers to continue working, but it's not necessary. The other way is forbidden. So when done, then we promote the release code by merging the release XY to the dev, and then from the dev to module branches, and then from the dev to component branches, and finally from the dev to the master. And then we tag all the branches accordingly based on our release procedure. We have a release procedure that how to tag, when to tag, what to write in the tags, and so on. I'm not sure if these documents are online and if we can make them online.
Make them.
Yeah.
And not public right now.
Yeah, so. And then when we are done with the release, and release is safe, kept, and tagged in the master, actually it's a time to make it public also. We have a public repository on GitHub named BEXIS 2 that is updated after any major releases. So when something is tagged on our master, it will also be pushed to the GitHub repository. For the GitHub repository, if you remember this branching and releases, actually this is our local Git repository. And then the GitHub repository also has a master on GitHub that when we publish something, like here, for example, we have published version 1 and then promote it to our master, safe kept it here, and then this version will go to the master branch on GitHub, which is publicly available, and other groups or contributor can fork from this one and then continue their work based on this version. So then it's likely that when we have this one, again, we will publish it and tag it. And then when we have here and here, the same should also be on our master on the GitHub repo. The GitHub repo is open source. I guess the licensing is LGPL. Yeah. So anybody that is interested in using the source code can fork it. If they have something to be contributed to our code base, they can make it and create pull requests for us. If there is a bug or there is a feature request or whatever, they can report it via GitHub or via our mailing list or any other means. I will update this slides with the proper links and URLs and emails so that if someone is interested in contacting us or making a pull request or making a feature request or whatever, there is at least a way to get connected. So contribution projects actually use the public repository. They don't have access, or they are not supposed to have access to our local Git repository. They can pull the release version, whatever they need, and then develop on top of it, publish their contribution freely. They don't need to contact with us, or they don't need to get their code integrated into our code base or whatever. They can just use it as they like. Even they can rebrand it by the means that we have provided for rebranding or by changing the source code. But later, if there is an enhancement done on their side, there would be a way to share it with us by, as I said, by pull request or by sending the changes. That's the whole story from the configuration and change management. Sorry, I forgot to stop in between. So if there is a question, it would be nice to have it now. Okay, thanks. And then the last, no, sorry, the next, the next talk is going to be implementation nodes, which is basically some insight to our coding style, naming convention. How do we get started with some tasks to implement features, for example, or to implement modules and so on. That's it. Done. Thanks again. Hopefully it's useful.
Thanks.